Hi Planet Earth!
Hello everyone!
We will present a very interesting project to solve some of the galactic problems.
When Apollo 13 started its trip to the moon, the team experienced a huge unexpected problem. The oxygen tank exploded. And one of the most dangerous problems was the lack of filters on board for machines that removed carbon dioxide from the air. While there were many square filters on board, the crew needed a round one for the machine. But one of the crew members took the square filter which was available, wrapped it in cardboard and fixed it with some sticky tape. Incredibly, it worked and everyone survived.
That's why our team wondered how else cardboard and similar material could be used in space if we want to make regular space flights possible. The challenge is how to make them cheaper.
The disposable bags that deliver cargo into space. The bags that NASA uses are mainly made from meta-aramid.
Ordinary cardboard can be made fire resistant if anti-fire material are added to it. Cardboard can also be coated with protective layer, for example, of aerogel, a material created by NASA. Aerogel coated cardboard almost does not burn. In experiment, a welding torch was used with a temperature of 3,000 or 4,000 degrees, and it took 3 minutes to make a fire of a piece of cardboard.
And even conventional cardboard is used these days to produce such cool things as VR glasses, guitars and even notebooks. When one thinks about space trips, however, packaging is hardly the first thing that would come to mind, but let us recall the first human casualty in space, the Soviet cosmonaut Komarov, died unfortunately because the parachute container was made of a very soft material which also failed to absorb the sticky condensate that started to accumulate on its inner surface, and for these two reasons the parachute simply got stuck and couldn't make it out. Another reason why the packaging becomes more important is a new generation of satellites, of spacecrafts, which will be made of simple aluminum. It's the conventional aluminum that we are all used to, and it is not the expensive alloys that are qualified for launching from Earth. And the components of these new generation spacecraft and satellites will be packed in special containers, and the task is how to make these containers to be fit for launch. Also, on the International Space Station, we can imagine some problems with the debris that come from the space, because the shields to protect against micro meteorites and other unpleasant things are available, but some of this space rubbish is too small to be discovered in advance, and at the same time too large to be stopped by the shields. And this rubbish can unfortunately potentially hit the International Space Station.
So these shields should be stronger, but the problem is how to reduce the cost and weight of the shields. Again, The inner layer can be made from cardboard-like material.
Cardboard is bendable but still very durable. In the coming years, low-cost production of such materials of very high quality will start, and this will dramatically reduce the weight of the spacecraft because such corrugated materials will provide good protection both at launch and landing. What we offer is multi-layered packaging based on cardboard which provides double protection. This double protection includes 3 layers of the cardboard itself and also 3 layers of packaging like the one that we are demonstrating now. And on board, the space crew can use the cells to create personal structures like open space, or what we call sometimes open office. It can be used also to build flexible walls behind which the equipment can be stored, and we know that sometimes in the space the equipment can easily fly away. And as the world produces a lot of products made of cardboard, for example, the eco-friendly furniture which is already made of it on our planet, we can imagine that when we go to Mars, it also can be used.
And after the arrival to Mars, the crew can make chairs, tables, cabinets and beds. On Mars, our weight will be lower, so this furniture will be durable. It consists of the identical parts, so you can easily replace them. No additional weight. On the site, it would be cut along the cutting lines.
And you can bind cardboard products using cardboard couplings or tubes of different systems which have already lost their integrity or ceased to perform their basic function. Simple materials often come to the rescue of astronauts. For example, they put pieces of packaging foam in the sleeping bag so that they put pressure on the astronaut's back, creating an illusion that the astronaut is lying on a bed. And it can be a special way to prepare the cardboard and then to put the pieces of the desired shape in the sleeping bag. For example, we can imagine a special section on the back of the sleeping bag where you can insert it. Finally, condensation is easily absorbed by such cardboard-like materials, and if something gets glued to them, packaging would be partially destroyed in the case it gets stuck, and the inner layer would come off together, for example, with a parachute, which is much better than when the parachute is jammed. Now we will model some space furniture. Thank you for being with us.
Thank you.